Today we're doing a Calorimetry Lab, and I'm starting by massing a calorimeter and then a beaker. Then I'm going to fill them up with 50 milliliters of water. So to begin with, let's make the balance 0, 0, there. And now I'm putting the calorimeter on the balance. The reading on the balance you should see as 39.6. 50 milliliters of water in the calorimeter using a graduated cylinder and remassing. So this is mass of calorimeter and the water, the 50 milliliters of water in the calorimeter. I'm tearing this again to make sure it's 0. Now I'm placing a 100 milliliter beaker on the balance, 50.0 grams. I'm measuring 50 milliliters of water again. This is the ionized water. Yet the meniscus, I'm using a dropper to add the last few drops. Now the bottom of that meniscus is on 50. Now I'm placing water in the beaker and massing again. And you should see 99.3 grams. Next, I'm taking the beaker and I'm putting it on a hot plate because I want the temperature of the beaker to rise to 70 degrees Celsius. Now I have the hot plate on 125. Increase the heat a little bit just to make sure this is not going to take too long. So, and I'm going to come back to this in a few minutes. Finally, I took the beaker off the heat and it's on the side. Next, I'm going to measure the temperature of the water in the calorimeter. Then I'm going to measure the temperature of the water that I just heated up. And then I'm going to mix the two in the calorimeter and measure the temperature again. The temperature of the water in calorimeter, and you have to try to swirl to make sure that everything is nicely mixed. So the water in there is 19. So it's 19 degrees Celsius. So I'm holding it in there for just a few seconds to make sure it doesn't change, and it hasn't changed. So that's the temperature of the water in calorimeter before anything is added to it. Next, I'm measuring the temperature of the water in the beaker that I heated up to about 70 degrees. 70 degrees. All right, so 71. I just poured the water from the beaker into the calorimeter and placing the digital thermometer in there and trying to mix the two water. So stirring and waiting for plateau. The temperature has gotten to an equilibrium or a plateau, which is 44 degrees Celsius. So final temperature is 44 degrees Celsius. For the second part of calorimetry, we're calculating the specific heat of an unknown metal. So make sure your balance is 0. Now I'm putting my calorimeter on the balance and remassing it 42.0. 100 milliliter of water in a graduated cylinder, which I've already measured, and I'm pouring that 100 milliliter of deionized water in here. So the mass on the balance reads 140.5. So that's the mass of calorimeter and the water. So next I'm measuring the temperature of the water in the calorimeter by using a digital thermometer, and my digital thermometer is reading 18 degrees Celsius. That's the temperature of the water in calorimeter. This is a 100 milliliter of water in calorimeter, and it's 18 degrees Celsius. Next, I have placed some water in a large beaker. It's about 100 milliliter of water in a large beaker, and I brought it to a boil. And next I'm going to put the clamp in here, and I have a thread to hang my unknown metal from this on here in boiling water for about 10 minutes. But before that, I'm going to mass a metal, place the metal on the balance and read. The mass of the metal cylinder is 65.0 grams. So that's the mass. Then next I'm going to hang my metal from the loop and immerse it in the water. Make sure it's just going to suspend in the water without actually touching the side. And I'm going to try to tie the loop in here. It should be completely immersed in the water, and it should not be touching the side of the beaker or the bottom of the beaker. So I'm just securing it. Then I'm going to lower the metal a little bit to make sure that it's completely immersed. I am checking the bottom, making sure that it's not touching the side or the bottom. So waiting for 10 minutes. The metal has been in the boiling water for about 10 minutes, and for actually a little bit more than 10 minutes. So what I'm going to do, I'm going to remove the top of the calorimeter so I can easily transfer the metal from the beaker in here. Wipe any droplets, any water droplets off the metal, so it would be just the heat of the metal itself and nothing else. So gently place the metal in the calorimeter, replace the top, put the thermometer in, and start swirling. You're looking at the highest temperature that the water would reach. 24 is what I'm currently reading. It just hit 25 for a second. There you go, 25. It's a digital thermometer, so easier to read. It seemed to be going back, so it's going back down, which means highest temperature that it actually got to is 25. It has reached a plateau. Yeah, now it's kind of fluctuating between 24 25. So now we know it's not going to go any higher, it's actually going to go lower. So the maximum temperature is in here is 25. So you're going to use the final temperature, which is 25, to calculate the specific heat of the metal by using Q of water and Q of the metal, and then measuring or calculating the specific heat of the metal. And based on that specific heat, you're going to calculate molar mass of the metal. So heat of neutralization, the last part of Calorimetry Lab, I'm using 1 molar hydrochloric acid, and I have already about 50 milliliters in there, but I didn't make the meniscus correctly. So I'm adding few drops to the graduated cylinder to make sure that the bottom of the meniscus is on 50. So that's 50 milliliters of hydrochloric acid, 1 molar. I'm also using 1 molar sodium hydroxide and measuring 50 milliliters of that. So this is 50 milliliters of sodium hydroxide, 1 molar. Then I'm making the bottom of the meniscus correctly by using a dropper to add the last few drops. There. So that's exactly 50 milliliters using a graduated cylinder. Next, I'm measuring the temperature. So placing the hydrochloric acid in calorimeter and real quick measuring the temperature. The temperature reads 19 degrees Celsius. Next, I'm rinsing my thermometer because I'm going to be using the same thermometer for sodium hydroxide, and using the towel to wipe that, and I'm measuring the temperature of sodium hydroxide. It should be the same temperature because they've been at room temperature for the same length of time. So 19 degrees as well. So rinsing that again, then transfer sodium hydroxide into the calorimeter as well, real quick, and replace the top. Place the thermometer in the solution and mix. Temperature currently reading 25, going up to 26, and that seemed to be the plateau, the highest temperature we have reached. The density of the solution is 1.02 grams per milliliter.